This is tutorial 8-4 in GIS tutorial workbook 2. In this exercise, we're going to be measuring spatial autocorrelation. And this is going to use the Moraine 1 function. And what it does is it's going to take attribute values as well as location to determine if there is clustering. Now, the thing with this tool, though, is it does not work on point features. So we're going to have to get these points into a polygon. And the way they're going to have us do that is they're going to have us use this 500 by 500 foot grid to spatially join the points, and then we're going to use the resulting shapefile to do the autocorrelation. So to do this, what we're going to do is we're going to right click on our 500 foot grid, go to join and relates, and you're going to want to make sure you're on this spatially join. The layer we want to join with is the calls for service. Item 2 we can just leave as is, and for item 3 is where you name it. Now the book gives you a really long name. I'm pretty sure you can only have 13 characters. Theirs is like 28. So I would just go with something small like call grid, maybe call grid 07, something like that. And click OK. Now this will take a little bit because there's going to be like 10,000 features that it's creating. Okay, that done. Now what we can do is we can open up the attribute table, and you can see that a lot of the counts are null. Actually, a vast majority of them are. So what we're going to do is we're going to go into properties, and we're going to get rid of those. And the way we're going to do that is we're going to get definition query, and we're going to type count greater than 0. We're going to click OK. And that got rid of everything. I'm just going to turn off the 500 foot grid so we can see a bit better. And I'm just going to change the color to an orange because that's kind of what they have, the dots. I'm going to turn off the dots as well. Okay, now that we have this, we can actually use the tool, the spatial autocorrection tool. So they tell you to use the search feature, but we're going to continue using the ARC toolbox, and you want to go to spatial statistic tools, analyzing patterns, and spatial autocorrelation. The input feature class, you want to use your call grid. And we're using count as our input field. We do want to generate a report. And the spatial relationship is zone of indifference. If you go through, you can read through of what each one is right here. To get this box to show up, you just show help. And we're going to start off at 1000. And then click OK. And what this is going to do, it's going to do a lot like the other tools where it gives us a z-score. And that will tell us if there's a relationship. Okay. And as you can see, our z-score is 2.3, which is higher than the 1.96 for a 95% confidence interval, showing us that, yes, there is a relationship. And if we click on this report file. It gives us the nice little graphic. This is where we are. Now you can get a 1.65 to 1.96 and have a 90% confidence interval that it's correct, but 95 is normally the standard. And the reason I say that is because they want you to go through and repeat this method over for increments of 100 feet up to 1900 feet. And I already went ahead and did that. And as you can see here, we have our best distance, our best z-score is at 1100 feet. Our worst being at 1500, which showed up as random. And we'll just do 1500. Now all the others showed up above the 95% confidence interval, except for the last one, the 1900, which showed up in the 90%. So it still shows a relationship, but just not as strong as the 95 confidence interval shows. And this is what the distance of 15,000 looks like. As you can see, it's pretty much right in the middle of the random. So that is definitely not one you would want to use. So the question asked is, can we reject the null hypothesis? And I believe we can. There is a strong relationship showing that for a majority of the distances that there is a strong relationship showing that there is clustering. So that's it for this tutorial.